Okay, guys, as promised, I'm going to go over the group work homework that you had to do in class today, the homework number 4. And number 1 asks about a gas where we change conditions. So we're going to use the P1 V1 over N1 T1 equals P2 V2 over N2 T2. And since everything is the same as far as number of moles and temperature goes, those go away. So we're left with P1 V1 equals P2 V2. And so we're solving for the final pressure, or P2. So P2 equals P1 V1 divided by V2, which is 0.60 atmospheres times 27 liters divided by 3.0 liters, and we get 5.4 atmospheres, which is answer B. So that's number 1. For number 2, it's a similar thing. It's a before and after where we've changed conditions. And the same thing, number of moles is constant, temperature is constant, but this time we're solving for the final volume. So we're going to rearrange the same equation up here, but we're going to arrange it for volume. And we get this right here. And when we plug in our information, we have 0.346 atmospheres. That's our initial pressure. Times 245 liters. That's our initial volume. Divided by our final pressure of 0.886 atmospheres. And when we plug that in, we get 95.7 liters, or B. Okay, for number 3, the number of moles doesn't change, but everything else does. So we have P1 V1 over T1 equals P2 V2 over T2. And we're going to solve for the final temperature. So we're going to have to rearrange our equation for this. So if we multiplied both sides by T2, it would get rid of it over here, and it would put it over there. And then we want to get T2 by itself. So then when we multiply both sides by T1, and that will go over here. And we would divide both sides by P1 V1, and that will go over here. So we end up with T2 equals P2 V2 times T1 divided by P1 V1. And when we put all that stuff together, we get 0.689 times 0.750 times 98, all divided by 0.443 times 0.500, which is A. So A is the right answer. And number 4, they ask which of the following gases will have the same density at STP. So it's important to recognize at STP, this is probably important to remember, gases with the same molar mass have the same density. So then it's just a matter of finding the molar mass of all of the gases, and you'll find the correct answer is D. That carbon monoxide and nitrogen both have a molar mass of 28 grams per mole. Okay, so let's take a look at number 5. In number 5, they ask you to find the molar mass. So they give you the mass, so we're going to have to use pervert NERT to find the number of moles. So number of moles is going to be PV over RT. And they tell you that the atmosphere is 760 torr. Well, it just so happens that 760 torr is the same as 760 millimeters of mercury, which is the same as 1 atmosphere. So our pressure is 1 atmosphere. Our volume is given as 124 milliliters, but we have to have that in liters, so 0.124 liters. R is 0.0821. And then temperature 120 degrees C plus 273.15, and we get 393.15 Kelvin. And when we work all that out, we get the number of moles is equal to 0.00384 moles. And they ask for molar mass, and they give a grams of 0.123 grams. So grams divided by moles, grams per mole, and you end up with 32.0 grams per mole. And that answer is D. So that's how you do number 5. Now moving on to number 6. On number 6, it has some pictures. And it's important to recognize in these pictures here. Well, first of all, it says, which of these 3 would represent what would happen. If you took number 1, it gives some information, but you don't really need any of the numbers. It says you're going to double the pressure and keep the temperature the same. Well, this is a piston, so the only thing you can change is the volume. So really what we're looking at is P1 V1 equals P2 V2. And they have to stay equal. So the initial pressure and volume, when you multiply those two numbers together, have to be equal to the final pressure and volume multiplied together. And they say that the thing that's being changed is we're going to double the pressure. So if this pressure is doubled, the only way that these two things multiplied together can still equal whatever this was over here, this must decrease. And the only option for decreasing is this, because this one would stay the same and that one increase. So the answer is C, or diagram 4. Okay, and for number 7, I'm just going to show you the work here and the key that I have. The first thing you have to do is write out our balanced chemical equation. So this is an HCl, in case you can't tell. Once you correctly write all of the reactants and products and balance it, then you're just going to start with 30 grams of zinc, change it to moles, use our mole ratio, and then we use this fact right here because it says at STP, and that helps us out. Because at STP, a mole equals 22.4 liters. So we can use this to find 10.3 liters is the volume. You could do it by finding the moles and then plugging it in the PV equals nRT, putting in the standard temperature and standard pressure and all that stuff, but it's a lot easier if we just use this relationship right here since it's at STP. So that's how we do all of these problems.